Hello, welcome to Electronics Education. I am Vincent Chang. So today we are going to continue our learning on the emitter follower and focusing on to solve the emitter follower based on another model, alternative small signal model called T model. So in the previous lecture, we have solved the emitter follower based on high prepend model. So for the high prepend model, base emitter collector, the up high current control current source beta IB. And based on the high prepend model, and then here's the outcome for input resistance RIB. Up high plus 1 plus beta, a parallel combination between RE and RL. And then the voltage gain, I don't know if you think this kind of challenging, right? If I'm asking you to solve the voltage gain by inspection and then supported by the high prepend model, right? A little bit too much. So you might be wondering, is there a better way, a more efficient way when it comes to the voltage gain? It's easy. Is there any more effective or easier way to solve this? For the output resistance, I think it's okay, right? It's okay. But the voltage gain seems a little bit too much. Let's now try to solve this, try to change the model from the high prepend model perspective to the T model. So now I want you to stop, to pause. For 10 minutes, try to draw the diagram based on the T model and try to repeat the calculation for the input resistance, the small signal voltage gain, and the output resistance. All right? So three things. Number one, so two things. So number one, just draw out, just sketch the small signal equivalent circuit based on the T model. So number two, just once the T models is finished, then you lay out the three expressions for the input resistance, voltage gain, and the output resistance. Let's pause for 10 minutes. All right, I'm back. Analysis by inspection. Analysis by inspection, but picture the T model in your mind, or just do a little bit of mapping, like what I just did. Emitter base, the resistance, the crucial component in the T model is what? Is the RE. What is RE? What RE stands for? The resistance between base and emitter looking into emitter. The resistance between base and emitter looking into emitter. So RIB tells us the answer is what? It's also the series combination between the RE, lowercase re, and the capital RE in parallel with RL, and bring back to the base resistance refraction rule. So RIB. So this is the outcome for the input resistance. What about the voltage gain? The voltage gain is this: VO over VB. And VB over VS is easy. Right? The ratio between the RS and the Rin. So the second ratio for the voltage gain is easy. So what about the first one? The VO over VB. So VO over VB is also another divider. What divider? The RE, the first component, the dividing between the RE and the green resistance. Another divider. Let me illustrate this. Let me try to elaborate this. If you stand on the, I try to make sure you can get this. You just grab the emitter terminal, right? Grab the emitter terminal, looking outside. What you see? You see the outside, right? You see the green one. The parallel between the RL and the RE. So that's the external guy. But if you stand on the emitter looking back to the inside, what do you see? You see the RE, right? That's the internal. So the internal and the external, they share the same what? They share the same current. They share the same current divider, voltage divider. So the VO divided by VB equals what? Equals what? Equals the external in the numerator, and then what's the denominator? It's the total. The voltage divider rule. Easy. You get it? Although it's online, it's going through the internet, I think you can still feel the passion and the strength. Then I want you to, the reason I show the passion, I think I want to teach you that you can build your confidence. And next time when you see this, boom, boom. Beautiful, right? And then, what about output resistance? But don't thank, I said beautiful, don't thank me. Thanks to the what? Thanks to the T model. That's the beauty of T model. That's the beauty of T model. Output resistance. So what's the output resistance? The first step, just kick out the VS, the signal source, and then remove the RL. So ground the left hand side of the RS, and remove the RL. And then what's the out? What's the output resistance? The resistance between the emitter and the ground, looking back, looking into the emitter. The resistance between emitter and the ground, looking into emitter. So tell me, what's the answer? What do you see? You see parallel, series, and parallel, right? S, B, R, E, and capital RE. S, B, R, E, and capital RE. Parallel, series, and parallel. But don't forget the resistance reflection rule. Don't forget the resistance reflection rule. Because the identity of RE has already been interpreted by the emitter. But the identity of the RS and the RB still belong to base. So we are looking into the emitter, so RE's identity don't change it. But the base guy, when take the base guy back to the emitter, has to be divided by 1 plus beta. So I try to solve this without sketching the small signal equivalent circuit. So that's the level I want to go. Or I want you to go higher. But for the beginner, you might have a lot of doubt. Either you have doubt on yourself, your own ability, your confidence, or you have doubt on the methodology. So in the next 5 minutes, I try to convince you the answer has no problem. Right? So let's just sink our level down a little bit. Going down to earth, just from scratch. Draw out the small signal equivalent circuit. SB base. And then what? Then this T model. What's the T model? Emitter base collector. The RE, IE. Current control, current source of IE. And then replace the transistor with the T model. 2. So RE, the resistance between emitter and the base looking into the emitter is RE. And then current control, current source. So pay attention to the phase, the direction. Don't mess up with the direction. And then the resistance between, there are 2, between E and the ground, RE and RL. So this is the overall picture of the emitter follower based on the T model. Based on the T model. So now, the voltage gain. The voltage gain, VO over VB, is the external, because they share the same current, right? External and the internal. They share the same current. Voltage divider. It's a voltage divider. And then output resistance. For the output resistance, the first step, ground. Just remove, just set the signal source to short circuit the signal source. So ground the left-hand side of the IS. And then the second step, remove IL. So what do you see? What do you see? You see SB, E, and E, right? Parallel in series, parallel, series, and parallel. And confirm the identity. RE's identity defined by the emitter. So don't change it. But for the base guy, the guy in the base, when it's taken from base back to the emitter, has to apply the resistance reflection rule. So you need to think about why it becomes automatic, right? Autopilot. So it's divided by, because you've used so many times. But sometimes you have to pause and ask yourself, why? Why I divided the base guy by 1 plus beta? Why? Because of this. Because what is IB? What's the current flowing through the base guy? It's IB, right? What is IB? What is IB? That's the difference. The current difference between alpha IE and IE. The difference between IE and so what? And so what? Then 1 plus beta comes out. So what? When you take the base guy back to emitter and you divide it by 1 plus beta, at that moment, At that moment, when you take the base guy back to the emitter and the width divided with 1 plus beta, at that moment, you already consider the effect of current control, current source. The alpha IE, the current control, the current source, the transistor effect, something from the third terminals effect has already been considered. It's the overall effect. It's the overall effect. If you don't believe this, the last resort will be you derive this. But you divide once, twice, you don't want to divide third times. It becomes your ability. It becomes your instinct. It becomes your skill of analysis by inspection. All right? So major takeaway, analysis by inspection based on the T model. It's a beautiful model. And then for the voltage gain, remember the external and the internal, the voltage dividing between the external and the internal. And then you can also apply the, let's try to do the one more time, based on analysis by inspection. SB, and in series with RE, and parallel with capital RE. And then base, emitter, emitter. The emitter guy, because you look into emitter, so don't touch it. So just duplicate, just copy. For the base guy, only the base guy has to be divided by 1 plus beta. I hope you receive something from this lecture and become more confident when you tackle this kind of classical transistor amplifier analysis. Thanks for watching.